Okay, let's go. More C++, yo. More lambdas. We love lambdas. Cool. Come with basic lambdas? Isn't this the same as just having functions defined elsewhere? I mean, so the point here is we have a greater function. It just returns the greater integer. Cool. Or, well, it returns whether a is greater than b. And the point is we pass in... And we're sorting... Gotcha. So we're sorting when greater returns true. So we sort element 1 and element 2 when, well, really, from start to begin. But we sort 2 elements when this is true. So a is not greater, don't sort. Don't sort. Sort. And then sort to get 99 there, and then it'll selection sort. It'll just go through. Okay. And then oh, and then the point is for each integer. Okay, this is weird. You may as well just do const auto if you don't know what's in this array, but sure, in this case we know it's ints. Yeah, sure. This is okay. Maybe not the most efficient way. It could do a constant, could do an int reference, but then you get into some semantics about whether it's more efficient or whether it's better to just to not touch these by having them untouchable, by making this const, and whether you want to do a reference to make it so that we're accessing these places in memory and we're not copying 13 from here to here and then printing it, copying this to here and then printing it. Copying an integer versus copying the address and then using it, I mean, they're both integers, so I think this is fine. The point is we're printing each element here. So you could just do for const auto for each and then boom, and use that for anything you ever use ever. So instead of converting greater, oh, excuse me. So there's there's an object in the standard library. I don't want to listen to this right now. This is too good. It's my game learning music. I sneeze. Excuse me. Okay. So standard grader is a function object. Okay. And the point is we're passing that so that this can be called with these. And it's like a temporary lambda kind of thing. The point is instead of looping through the... Well, why are we talking about a loop anyway here? I'm not sure what he means with the loop here. The algorithm library has parallelism, so things that are happening, I guess, at the same time, more efficient somehow, maybe, possibly. Why is it so fucking hot right now? We're back. Oh, excuse me, turn the AC down by 1 degree. 73 now. Okay. Oh, cold chair. Okay, we're good. Okay. Create a struct student that stores the name and points of a student. Okay. Do this in one file. Name and points. Okay. Also need an array apparently. Well, let's see what else we need. Please, what the fuck is that? Okay. An array of students. How many? Some number. Oh, to find the one with the max. Okay, I think I know what we have to do here. Alright, we need an array now. Okay. Well, we'll just do type deduction. How are we doing this? Some double brace action. Hold. I mean, it should be able to, no? I mean, we don't need any more braces. Shouldn't. No. Hold. Yeah, I guess we do have to specify. Not a big fan of these. I prefer standard vector, but it's fine. Hold. Yeah, it's 1, 2, and then them. 1, 2, and then the. Oh, I messed up on the braces. Okay. Create an array and use standard. Oops. Max element to find the student with the most points and print the name. Takes to begin and end. Takes 2 parameters. So max element, isn't this just greater? It takes the begin and end of a list. Oh, gotcha. Standard max element, duh, takes the beginning and ending of a list. And a function that will return true in this case. And it will return, what, the one that... Okay. Okay, and then I'll have a lambda that takes the student and then compares the points. Okay. So if we do, what does standard max element look like? Is this, what is this from? Is this from functional? Okay. Okay. I'll make a lambda now. We'll do auto. Do const expression, I think. Oh wait, hold. What the fuck am I doing? Hold. Wait. It's initialized to be empty capture clause. And then it takes this. Yep, same shit. This tab pack. Oh. Hold. What's the warning? Okay, cool. Right, true, if this is less. Okay. And the point is max element will compare the first two in this. And I'm going to do compare the first two. And then is it it's saving it somehow? I mean, I guess it doesn't matter how it's doing it. There's a function here somehow doing something. And it's called void max element. Well, actually, what does it return? It returns an iterator, a pointer to that element, seems like. So I'll make what I can guess would be it in a sec. So, or, well, it doesn't matter. So basically the pseudocode would be pointer to an element. What are we doing, a T pointer? Are we doing... I guess we could do an auto. So we could do a pointer to, okay, well, whoops. A pointer to whatever the hell, and this is called max element, right? Oh, max element oops, I forgot, it's a standard library thing, it has an underscore in it. And it takes something and a something, and we take a pointer to that same type of thing, A, and then another pointer to another type of thing in a specific array. So this is the beginning, we'll just say begin, or we could say start, end, and function, and this would be, how do we, because I'm thinking void, so a pointer to a void returning function, or a pointer to a bool returning function, and we'll just call it x, but what are its arguments? And it takes 2 elements, and we could say it's auto first, auto second, I think. Something like that, that's the point. So it's a function that takes a pointer to an element called the start, a pointer to another element of some particular value called the end, and then a function that returns a boolean is called x. It's a pointer to a function called x that returns a boolean and takes 2 of the same type of object that's being pointed to here, but not, yes, okay. And then inside it, what max element probably does is it checks, it says pointer to a const. I guess we could say it's a const auto pointer, a pointer to the same thing, or this could all be template type name t and replace auto with t in all of these cases. That would work too. Const auto pointer, and it's called max element, and it's initialized with, we'll just say it's null pointer, or it's by default initialized with null pointer. Cool. Okay, we'll store all points to biggest element, something like that, and we say if, or we just say if the first is less than it's the second. The point is we call that function with 2 elements. So the point is we're calling it, right, with, so we're calling x with start, right? So index with 0 and start 1, or we could just increment the index. So we could say whatever, standard size t, index, okay? So it starts at 0, and we'd say index, and then we could increment index. Well, I guess we should probably, right? I think that makes sense. Maybe. Actually, I'm not sure if it has to. I think this is okay. This is tricky syntax, but I think that would work. So we call it to see which is bigger, and we say if this whole guy is true, then max element oh, I guess we would have a loop. Really, that's how this would be. So this would just be index plus 1, and then 4. We could pass the size, or it would determine the size. So whatever, and I size blah 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 whatever, and it would go through this entire array. So we'll just say loop through entire array. Okay, and then max element, excuse me, if this is true, then it points to the second one. Start, hold, if I do start and I index it, I think I have to get the address. Because the address of the value that I get, because if I subscript this array, I'm going to get the value of what's there. All right, so if I subscript pointer to the first element and a pointer to end, and I subscript that array, I'm going to get the value, I'm pretty sure. So we're going to do start index plus 1, like that. Or I could save begin and then just add the index plus 1 to it. You could do this either way. We loop through the array, and we go until we have the biggest one. And otherwise it's false, so it's ignored. So the point is we go to this one and we say, okay, is this smaller than this? No. Oh, or I get true if the first is less than the second. So if this is false, the problem is the comparison part. Why is it taking... All right, not a big deal. Okay. So we return whether the points are like that, and this returns a pointer to the element we're looking for, and we're going to say student, or we could say a pointer to the a student pointer most points student, or we could say highest scorer, whatever. Okay, and we do greater lambda. Hold. Oh, good. Doesn't take this. Awesome. What if I said auto? That would be fine. And what is this returning? This is returning an iterator in the standard array, so it's not a student pointer. It's actually the iterator from the array. So it's that standard array's specific iterator, and we don't know what that is. Okay. And then if most points student, then wait, is it not? It's not a pointer? Hold. Oh. What is the type here? Can I subscript it? I can. And I can do that too, but I can't check if it's valid like this. Scary. So I mean, does that mean it's a pointer to a student specifically? It's probably, well, actually, let's see. Okay, I don't even have character output yet. Yeah, can't take it. Can I do dot? Oh, what the fuck? What is that? I have no idea what this is. Can I do this and then get dot name? No. Can I? Oh, I can, so I have to subscript it. I can't dereference it. So it's a pointer to an element, it's an iterator that's pointing to an element of this array that's a student, but I have to subscript it with 0 to get it specifically. So we'll say oh, great. Oh, it is Jack. Okay, good. What if we did Maurice now has 80? Huh. Okay, max element. Works for me. Cool. Standard sort and a lambda to sort the seasons by ascending average temperature. Sort and return. Okay. All right, well, I mean, I'll guess I'll just copy this. Sure. Struct. So we have a season that has a name and a temp, and then I'm going to create a lambda here. Wait, hold on. Use standard sort here. So I need a lambda. So I'm going to say auto season, or greater temp, auto greater temp lambda. And it's going to be this. No capture clause, empty capture clause. It takes a what? It takes a const season reference and then a const season reference b. Okay, and what does it do? It returns a bool. So we could say here bool, and it returns a hold. What is it? What does it do? It's sorting by average temperature. So it is. We're comparing floats then. Okay. So return. We want to return true if we need to swap. So we return whether the first is less than or is greater than the negative. So return A average temp is greater than B average temperature. Oops, what the fuck am I doing? Okay. Compare to season, or compare temp of 2 seasons, or yeah, 2 seasons. Sure. And then we could say standard sort, because this is already in functional, or oh, algorithm, duh, whoops. Standard sort, and we're taking seasons begin, seasons end, and then greater temp lambda. Okay. And so the oh, it's actually the opposite. Hold. So, oh, because it sorts by descending by default. Okay, interesting. All right, why I prefer, or well, I like ascending. We say first is winter, then spring, then fall, then summer. We don't say descending. That's it. Use a lambda to sort them by ascending average temperature. That's it. Like that's cake. Oh, I mean, sure. I guess you don't have to name it. So I mean, you could just say, boom, 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 boom. And then we could say, lambda to compare 2 seasons. Cool, right on time. Pop. Please. My computer is ass. That's what I'm telling. Wait, okay, is it not? Is it just me? Huh? I fucked up? Oh. See, my computer's just, I don't know. It's a good computer. Lambda captures. So now we can somehow bring, I'm pretty sure, objects into scope from the same function. Okay. Lambda captures. Just this example, we have an array. We're saying whether something is found. Alright, that's time. Continue more tomorrow. And that's it. Yeah, we'll start from scratch tomorrow. I have some spells to implement. 2 hours and 50 minus 30 minutes because I have to cook. Damn. Okay, more tomorrow.